Do you ride a motorcycle? Have you ever had a crash that wasn't your fault? Then you may have asked yourself, why didn't they see me? Well, psychologists have been investigating the reasons that people have crashes, and they found that some hazards are harder to spot than others. This video is going to go through some of those reasons. First of all, let's start by putting you into a hazard perception clip. You're going to be the car driver looking out for danger as you drive along the road. At the T-junction ahead, you're going to turn right. So what happens next? Any idea? Let's have a look at the full clip and see what the actual hazard was. As we were turning right, we get surprised by a motorcycle overtaking stationary traffic to our right. These sorts of collisions are a big problem for motorcyclists. Typically, they make up only 1% of traffic on UK roads, but around 20% of the fatalities. That doesn't seem very fair. So why do riders crash? Top reasons include rural bends, going in too fast, maybe underestimating the amount of curvature and then losing control, but also other vehicles failing to give way at junctions and pulling out in front of motorcycles. Or they may change lanes without checking for overtaking or filtering motorcycles. In fact, more collisions are caused by the actions of other road users than by the motorcyclists themselves. So why do car drivers crash into motorcycles? Are they ignorant, arrogant, unobservant? We're going to look at 3 of the key reasons why they might pull into the path of motorcycles. But first of all, we're going to start with a little activity. I'm going to show you a picture of a road scene, and I want you to find the dog. You've only got 5 seconds to find it. Are you ready? Did you find the dog? Let's have another look and see where it was. Did you spot the dog in the tree? No? Maybe you spotted the one on the roof. Or perhaps the other dog on the roof. Or maybe even the dog that's sitting on the windowsill? If you didn't spot any of those dogs, don't worry. That's what happens to most people. Just going to show you a little video now of somebody searching that picture trying to find the dog. You're going to see their eye movements on the screen, represented by little circles which show what they're looking at. And the lines joining those circles show when the eyes are jumping. As you can see, they're searching the pavements, the road, everything that's quite low down in that picture. So why didn't you look in the tree or on the roof for the dog? Well, because dogs stay on the ground. It's common sense. And if you want to find the dog, in the real world, you look where you know dogs should be. In other words, our experience of the world guides where we look for dogs. In the same way, experience guides where we look for hazards on the road. And we need to develop and learn where certain hazards come from in order to have the best chance of spotting them. To see whether that applies to the first video we showed you, we asked 112 car drivers and motorcycle riders to watch that video searching for the hazard. We've got 2 videos here, showing the eye tracking of a car driver and the motorcyclist looking at the road as they approach that T-junction. Can you work out which one of these is the car driver and which one of them rides a motorcycle? Any idea? If you thought the one on the bottom was the car driver, then you'd be right. And we can tell this because our driver was looking to the left, even when the car was pulling out. Which means that when they look back to the right, they've already nearly collided with the motorcyclist, which they had no idea was coming. In contrast, our motorcyclist checks to the right on approach and sees the motorcyclist coming in the distance. When they then pull out, they're already looking to see if the motorcyclist is overtaking the stationary traffic. This gives them the most advanced warning that that motorcyclist is going to be a hazard. This happens because our motorcyclists in this study have got knowledge and experience that our car drivers don't have. They know where motorcyclists can come from, and car drivers just don't know this, in the same way that if they've never seen a dog before, they wouldn't necessarily know to look for the dog on the ground. When we look at the data from our 112 participants, we found that on average, those participants who ride motorcycles looked at the approaching motorcycle in the hazard clip sooner than car drivers. They spent longer looking at the approaching motorcycle than our car drivers. And they scored 33% more points on the hazard perception task for this clip. All of these were significant, suggesting that our motorcycle participants were much better at spotting and identifying this hazard. So let's return to our question, why do car drivers crash into motorcyclists? We now have our first potential answer. Drivers don't know where to look for motorcyclists. They've not ridden a motorcycle, they don't know what motorcycles are capable of, and they don't see them often enough on the roads. So it doesn't occur to them that motorcycles might be overtaking or filtering. Let's look at another reason why car drivers might crash into motorcycles. Let's have another activity. I'm going to show you my itinerary for my holiday, and I want to know where and when I'm planning on going on vacation. Now it's going to be quick, you've only got about a second to read it, and it's going to appear in the white segment on the left of the screen. If you're ready, let's go. Now, if you said I'm clearly off to Paris in the springtime, then you'd be correct. But did you notice anything odd about that sentence? Let's have another look. Now, some people take a long time to notice this, but actually, the word the is repeated twice in the sentence. We don't notice this because we don't expect it. We're expecting the sentence to be grammatical. We don't pay much attention to the small words, and so even though we're looking directly at the sentence, we don't really see what's there. In regards to driving, this form of error is often called a look but fail to see error. These errors can typically occur when we're pulling out of side roads into main carriageways. So, for instance, junctions, which we're very familiar with, we might expect to be free of traffic at certain times of day. However, if there is traffic present, we're probably going to expect to see a car, maybe a bus, maybe a van, but we're unlikely to expect a motorcycle. Again, this is because as car drivers, our experience of motorcycles is very limited. Here's another little activity for you. What word will appear next? Did you see it? If you said cars, you're correct. But did you spot the finer detail? The letter C of cars was made up of small b's. The letter A was made up of small i's. The letter R of cars was made up of small k's. And finally, the letter S of cars was made up of small e's. So yes, if you said cars, you did get the correct word on a grand scale. But it meant that you might have missed that finer detail which was hiding all of those bikes. The reason this error occurs is because the brain is designed to process bigger things first. So, if we look down a road before we pull out, typically a fixation, a glance down the road might last half a second or less. That length of fixation may not be enough to allow processing of smaller objects. It's fine to work out that the road is empty, or even that there's a large car or truck coming towards us. But motorcycles, because they're smaller, need a longer time for us to process them. Sometimes even nearby motorcycles might be hard to see. This Think campaign poster shows an approaching motorcycle that's really quite close. However, the background camouflages its approach. If we zoom in, there they are. And now we can see a motorcycle coming towards us with daytime running lights. But they're still very difficult to spot when hidden by the trees in the background. So let's go back to our question. Why do car drivers crash into motorcyclists? Now we have another potential answer as well. The small size and unexpected nature of motorcycles just makes them harder to identify. In fact, both of these hazards can combine to create extra danger. So let's have a look at this clip. We're driving along and we come to congestion ahead. It's likely that your sat-nav tells you at this point that there's a faster route if you're willing to take the road to the right. So off we go. And then almost have a collision with an overtaking motorcycle. So why does this near collision almost occur? Well, first of all, our driver does not expect a vehicle to overtake. They'll be thinking about other vehicles like cars rather than motorcycles. Even if they do look in that side mirror, however, then they still might not pay attention to what's in the mirror because that motorcycle is narrow, small, and might not activate the visual system in the same way that a much larger car would do. This might mean that by the time they actually see it in their mirror, it may be too late. But let's imagine that somebody does look in the right direction and can identify that a motorcycle is present. There's a third error that they might fall foul of. They might still make the wrong decision. To explain how this might happen, let's look at this image showing two approaching vehicles, a car on the left, a motorcycle on the right. The green bars beneath each of them represent the width of the image that each vehicle is projecting onto the back of our retina, which is vital for us to see. Now, as those vehicles get closer to us, their images will expand and the width that they take up on the retina will increase. The red portions of the bar show how much that image is increased on the retina, and in absolute terms, this is much greater for the approaching car than the approaching motorcycle. In fact, in some instances, narrow motorcycles that can be quite far away can quickly get much closer to us, but with only a very small change in the width of their image on our retina. Sometimes its changing width can be so small that it falls below the threshold of what our eyes can detect. This motorcycle can seem far away for quite a while, and then suddenly the motorcycle is upon us. This isn't due to the motorcycle accelerating on approach, but because the narrow profile doesn't expand much on the retina and makes it very hard to judge motorcycles' approach speeds at far distances. In other words, the narrow profile of an approaching motorcycle, because it doesn't expand much on the retina, means that it's much easier for us to mistake the speed or underestimate the speed of its approach. So let's go back to our checklist. Why do car drivers crash into motorcyclists? We can now add a third reason, which is that it can be hard to judge the speed and distance of an approaching motorcycle because of the small image taken in by the eye. Do any of these reasons excuse the actions of car drivers? No, but it does help to explain them. Not all car drivers are ignorant, arrogant, or even unobservant, but many of them will fall foul of these psychological biases when driving, and that makes them more dangerous around motorcycles. If you ride a motorcycle, why not tell your car driving friends about these biases, and they can try extra hard to look out for motorcycles when driving. We're certainly going to be telling as many car drivers as we can about these factors. But in the meantime, if you find yourself in a similar situation while on your motorcycle, perhaps give these drivers a wider berth just in case.